All right, so I think as many of you know, the Susan Mahan Niebur is our Early Career Award, and it's given to early career scientists who have made a significant contribution to the science and or exploration communities. And so recipients are researchers who are no more than 10 years from receiving their PhD, who have shown excellence in the field and demonstrated meaningful contributions to science and exploration communities. Susan Niebur was former NASA program scientist and founder of the Women in Planetary Science Project. And she established the first ever early career fellowships and workshops for planetary science programs while at NASA headquarters. And she was known to support students at every level with personal and professional development. So this year, our Niebur Award for 2018, our winner embodies the attitude and outlook of life for which Susan Niebur was so well known. Dr. Rachel Klima is our winner for this year, and she is one of the premier airless body spectroscopists of her generation, as I'm sure you're all very aware. And with over 40 peer-reviewed papers about the Moon, Mercury, Vesta, and other asteroids, we are excited to choose her this year. She, outside of her published papers, her knowledge has put her in great demand. She has been sought after to play important roles in many NASA missions. Dr. Klima has a broad array of experience throughout the solar system as well. She's worked on mission teams from Mercury through Europa. She's worked with the Dawn mission, and she's participated in development, data collaboration, and calibration, and data analysis of the Moon Mineralogical Mapper instrument on Chandrayaan-1. So there's a lot there. I'm going quickly because we want to get to her talk, but currently she is serving as a member of the project science team for the Europa Clipper mission, and she is also the deputy PI for the Survey APL Vortices team. So I will close with, she's even had an asteroid 9287 Klima named for her. So if you'll please join me in congratulating her, we'll welcome Dr. Klima to the stage.
Greg, do you want to be part of this?
Not as good.
Is there a good place here?
It's better over there. Okay.
Bear with us, please. We won't let this take away from your talk.
That's okay. We're running out of stuff.
Mash on in nice and close. That one where everyone smiles. All right, thank you.
Yeah. Can I sit this down first? All right. Well, this is going to be a very different talk than I'm used to giving, so I hope that, that it's interesting to folks. I want to start by just saying that this award means so much to me. Susan, I attended her first early career workshop that they ran at South Shore Harbor for grant writing. It was my second year of grad school, I think, and I remember going with Noah and learning so much about what the point of writing a grant was and what the point of communicating your science to the community. And, you know, there have been wins and there have been a lot of losses over the years. But I think what I learned there about how to refocus yourself and frame your science in a way that communicates to the panel what the point is. It helps both to write the proposal, but it helps to guide you when you get funded. And you can go through it and say, why am I doing all this? Why am I sitting writing this IDL code that's like, keeps crashing, and then I lost this, and, just to go back to the point of why you're doing it all. And I worked a lot with Susan after she left NASA. So when she got ill, she went to her own company, and because she wasn't able to spend as much time in the office, she had 2 young children. And she did a lot of interviews. So she started up these interviews with women in the planetary science field, and she did an interview with me, and I was a lowly grad student at the time, but I had helped write a proposal that got funded for PG&G. And so I was a very fortunate grad student in that I had the money to do the research that I wanted to, and I also had a future, an immediate future, knowing that I had a postdoc there for me when I graduated. So Susan interviewed me. She helped me clean up my interview, which sounded like a Valley Girl and was kind of embarrassing. And we continued to work together and talk together. She gave me comforting emails. So I was trying to write my ill-fated Dawn participating scientist proposal. And through being a young mother. And the reason I put a picture of the moon here, besides for the fact that we all love the moon, is that shortly after she died, I remember driving home this back way that I used to take from work, and there was this gorgeous, gorgeous full harvest moon. And I just remember thinking about everything that many of my mentors and Susan had done for me and how much I appreciate it. And then I tried not to crash my car staring at the beautiful moon. So, all right, so moving on. I'm going to go back in time, and I'm going to tell you a little bit about my career path. And it's not great when a lot of people's response is like, your early career? But I had kind of a funny beginning to my career, and I started a little bit later. And I think one of the big points of this whole thing is that learn what you can along the way, and you can always take different turns and twists and get to where you want to be in life. So as a kid, one of my favorite things to do was camping and staring up at the stars. And those were the 2 things that kept me grounded through most of my childhood, through my adolescence and puberty, which were a disaster and full of a lot of veers off the track of life. But it was something that stuck with me, and that I, despite a very turbulent high school, I ended up returning to. So after high school, which I didn't do poorly, but I was not like the ace valedictorian or anything like that, I decided to go to community college and try to figure out where I wanted to be. My parents had divorced, and I came back so we moved to Germany. We moved back from Germany and left my dad there. So in '86, I was no longer on the same side of the ocean as my dad and only saw him a couple times a year, which was really rough for me since we were very close. So anyway, after all of that turbulence and getting through high school, went to community college to try to figure out what I wanted to do. And I thought, well, maybe I should do foreign languages. I could get back to Germany. It would be great. And then I realized politics, I don't actually really like people that much. I mean, I do like people, but I don't like politics that way. And I thought, well, maybe anthropology. And then there's still a lot of people involved in anthropology. Then I'm like, what I really love is rocks. And I signed up for this trip to the Burgess Shale. And it was amazing. And I went with one of my high school friends, and we learned so much about the geology. And then I took a trip to Hawaii and went to the volcanoes, and I'm like, oh yeah, this is what I loved. I completely, it's not that I forgot, but I forgot that it's a possibility to do that. So anyway, I graduated, and my parents were not in the science field. We didn't really realize that you could go to grad school without having a lot of money to pay for it, that there were possibilities like stipends. And from community college, I went to University of Chicago, which fortunately was cheaper because I had a couple years of community college to take care of credits, but we were flat out of money. There was no way I thought I could go to grad school. So there was a lot of get a job, get a job, get a job. Okay, we paid all this money, get a job. So I started out, people didn't want to hire, so I was interested in doing geology, and the only thing I thought I could do with a bachelor's would maybe be environmental science of some sort. And I applied for jobs in Chicago, where I grew up, and they didn't want to hire a 20-whatever-year-old, 21-year-old woman to like work on these sites. It was not really something they were doing at that time. I applied for jobs for 3 months, finally gave up and decided I had bills and went to a temp agency and got a job in a law firm doing very little interesting work. But very quickly, my bosses decided I don't want to say smarter than I was a very competent temp relative to what they were used to. And they made me a permanent employee. And they told me, I know this isn't what you want to do. I know you want to do geology, but this has been good. We'd like you to stay here, but we understand that you're not going to stay here forever. And like a month after that, my friend who had my resume gave it to some people in her department at DePaul University who did environmental work. And they wanted to hire me. And I ignored the phone call because I actually really liked the people at the law firm. And then I ignored the second phone call. And then I ended up going there. And I thought, well, this is great. They told me about going to sites and messing with dirt and doing all kinds of kind of geology things. And yeah, it's kind of also not geology. I wrote a manual for underground storage tank removal. I wrote proposals to NIH for some training that we did for workers, which actually I did out here. So I almost wanted to call the talk there and back again, because I'm kind of a hobbit anyway. But I used to teach in East Palo Alto. I taught minority worker training grants through a program that Al Gore had. And it was really fulfilling, and it was really interesting work. But we got to a point where they're like, okay, now you got to start cold calling Farmland Foods and telling them they need OSHA training. And as a 23-year-old girl, going into a place trying to tell people how to be safe and wear their PPE was like a very unappealing job. So thankfully, my beloved husband said, you can't do this. This is not what you were meant to do. You need to get back on track. You need to go to grad school. We've got the money now. We'll make it work somehow. And we had no cars. I walked to UIC and applied there because it was an hour. It was about a mile walk from our house. And I applied to do hydrology, thinking at least I could get a master's in hydrology, maybe get a better job in environmental work. And when I got there, I'll go to the next one. So anyway, I got there. I enrolled in grad school there. Found out that I could actually start right away. I thought I'd have to wait a year. And they're like, no, don't worry. You don't have a GRE score yet. You can take that before you graduate sometime, And here's a TA, or we'll probably be able to get you an RA. Just come on. And I'm like, what? I could have done this years ago. So anyway, I started at UIC, and I'll go on to the next of that after this. So the lessons that I learned basically from that time working in another field was that sometimes things don't turn out quite the way you expect. You might think it's geology, and it's maybe not. But that's okay. Take the skills that you can. I did grant writing. I stayed up all night with one of the, basically the head of the company, writing proposals, trying to make my case to the NIH about why it was important to fund these worker training programs and to get them working in their communities and to build better communities. And when someone in your family says, you look miserable, you need to make a change, listen to them because they love you. And it's never too late to change directions. So anyway, I changed directions. I went to UIC thinking I would do hydrology. And Peter Doran was my advisor there, who some of you may or may not know. He does astrobiology, and he has he had some Mars grants at the time. And I asked him about what hydrology projects he had, and they all sounded kind of boring. But he had this Mars globe, and I knew he had this Mars grant. So I asked him about that, and actually very few people were interested in doing the Mars work because they really did want to go into EPA or go into some kind of environmental work. So what I ended up doing was looking at pattern ground on Mars. And I measured a lot of cracks in the ground and a lot of angles, and I looked at a lot of data in a school that at the time, there's more planetary there now, but I was the only planetary geologist to speak of. We had just gotten the Mars Odyssey data back, so I was able to look at the gamma ray and neutron spectrometer data, which was very exciting. But I realized that what I really wanted to do was to learn more about using the different wavelengths of the electromagnetic spectrum to probe the material that you're looking at. Because, looking at the pictures, you could only tell so much. I mean, are these formed by water? Yes, now we know there's a whole bunch of water involved in everything. But the region I was looking in, Utopia Planitia, is actually relatively dry relative to the rest of Mars. So are these desiccation cracks? Is it past water? Is it current water? It's really hard to just distinguish that morphologically. So I tried to open test data, and I spent way too long trying to open it and never managed to get there. And I decided I need to go somewhere else. I need to go somewhere where I can learn about spectroscopy and where I can learn about all of these tools that we have when we explore other planets. So fortunately, I met Carly, and Carly accepted me into grad school at Brown, and I completed my master's at UIC and then moved to Brown. And my GIF even worked with my entrancing rainbow here. So over the rainbow, into the glory that was to come. So shortly, because I had sort of started with this focus on Mars, Carly had this proposal that was in the works called Taking Apart the Rocks of Mars, which was really exciting. It was taking Martian meteorites, splitting them into mineral separates, measuring them with all kinds of spectroscopy so that we'd have ground truth for Mars, since we don't have samples. And it did get funded, and this was our kickoff meeting, which was in November. It was on Carly's birthday, after I had arrived at Brown. And this is one of the pictures that when I look back, I remember when we took it, like 2 people's eyes are closed. I feel like I look like a weird mountain or something, I don't know. But I'm so happy we have it now. So, other life lesson, even if you think a picture's terrible, keep it, because you'll appreciate it one day. But one of the things that we did, and this is due to Darby and Janice, we pulled down these models of pyroxene and olivine, because the question we were looking at is, we have these spectra of a pigeonite, and at some wavelengths, it looks like a dead ringer for an olivine. And, is this messing up our characterization of olivines on Mars? Because at these longer wavelengths in the mid-infrared, they look so similar. And so we looked at these molecular structures of pigeonite and olivine and other pyroxenes and thought about the vibrations and really tried to visualize what was going on. And this has stuck with me through all of grad school and everything, just trying to visualize what's going on. And I'm sure I oversimplify it like crazy because I'm not a quantum physicist, but what's going on inside the minerals and what's producing these absorptions? What are we really looking at? Not matching squiggles, but what are causing those absorptions and what are they telling us about the rock? So anyway, then we celebrated Carly's birthday, and I promise I still have a little bit of time, so I will speed up my nostalgia here, but you don't get this opportunity very often, so. So anyway, we got back from this, and Carly said, we've got these pyroxenes, and it was about 100 pyroxenes that Don Lindsley had synthesized over decades that were entrusted to Darby. She's been collecting up all kinds of minerals to do spectroscopy on and to do integrated spectroscopy on. And I think Carly's words were, we really need someone to mother them. And I said, okay, that sounds great. And I spent the rest of my grad school basically characterizing these with electron microprobe, looking at the Mossbauer spectra, looking at near-infrared through mid-infrared spectra of them, and trying to figure out when we can integrate these data, what can we tell about them? What can the lab measurements tell us about the potential for those spectra to be used to do things like geothermometry on other planets? And what do the spectra that we measure on other planets tell us about the pyroxenes? Oh, I'm not seeing my notes on here. I've never written notes for a talk before, but I thought this is a little different. So anyway, I worked on that like crazy, got close to the end of my time there. We had measured some of the Mossbauer spectra, but not all of them, and Darby got this new hot source for the Mossbauer. And it meant we were going to have to, if we were going to get through all of these samples, or through the 40 of them that we ended up doing temperature measurements on, we were going to have to change the temperature every 2 to 4 hours. So I spent a week up there changing them in person and driving through snowstorms to actually change samples. But when we got onto this stage, we could do most of it remotely, and she was going to change between samples. And she told me, it's fine. It's great training if you want to have a kid. And I started grad school at 30, and so it was in my mind. In fact, I was going to mention it earlier, but through grad school, I spent a lot of time trying to schedule out when it would be okay to have a baby, because when I had been at UIC, and I don't know, I'm going to say it anyway because now I'm up here and rambling, but we had a lot of people interview for a new position, and one of the people who interviewed was a woman who was extremely pregnant. And the comments from some of the people, they weren't blatant, but it was very clear that they were not sure how committed she would be. And the only reason, she gave a fantastic talk, the only reason that I could see as a grad student that they were making those comments is that they're like, she's going to have a family. Is she going to be committed to being faculty here? And so that scared me. And I did not want to be at LPSC visibly pregnant. I didn't want to be interviewing for a job visibly pregnant. But I knew I needed to probably squeeze it in sometime when I had some flexibility in my life. So I would sit and draw timelines about like, okay, if you get pregnant now, it's going to work great. So anyway, after this, my timeline got busted because I was working on writing my dissertation, or about to really get into the throes of it, and I found out that I was pregnant. And this was actually right before I went up to visit Darby, and I took the test because I was scared about going into this super hot Mossbauer source while being in my early months of pregnancy. But Darby gave me great advice. She said, work really hard now, work really hard for the first 6 months, because after that, it's going to be really, really hard to focus. And I was very fortunate to have a great little guy who would sleep on my desk at Brown. So this was, I finished my dissertation, defended, walked, and then Alex was born in August. So he was born like 3 months after I defended, basically. And yeah, so Carly was sweet and allowed me to work from home a lot during that time, which allowed me to work when he was sleeping and be awake when I needed to be. And he'd come in and sleep on my desk very wonderfully and stare at baby Einstein videos on the iTunes visualizer. And then, so he understood what life was about, right? Eat, sleep, spectroscopy. So the lessons I learned in grad school. And I'm also in postdoc. Actually, I thought I had switched these. Let me go to this slide first, too. So anyway, after that, I was at this crisis point where Darby had convinced me to teach a class at Mount Holyoke for a semester. I really did enjoy teaching, but it was an 80-mile drive back and forth. So I was doing my postdoc at Brown. I had committed to teach this class and commute once a week up and back to Mount Holyoke. I was working with the Dawn team. I was working with the M-Cube team. So things were going well, and I had funding, and I thought, I can just stay here. This is okay. But I had this opportunity to go to APL, and I thought, I shouldn't just stay in the same place forever. But it's a big jump. And I mean, talking to Louise Proctor, she said, well, there's a little flexibility, but we really want to see you in the office. We want to see you there on a day-to-day basis. You need to build collaborations with people. You need to integrate into the group. So, it's not going to be a work-from-home life. But after, stressing over it over and over, I decided to go ahead and do it, and it really turned out to be fantastic. And that's because of the community, and it's people like all of you guys here. We have an amazing, amazing community. And if you are at a school where you don't get to interact with the community as much, go to meetings and mingle with them, because there's a lot of really nice people, and I'm going to gush about it a couple more slides. But these are just a few favorite pictures. This was from the Dawn launch, and Angioletta Corradini is in this picture, who the next talk is honoring. Well, it's honoring Barb, but you know what I mean, named after Angioletta. Couple of things that I learned in grad school that I'm going to go back to on the other slide was that you should still try to do things other than just eat, sleep, and spectroscopy. And this was my big Uber project that I decided when M-Cube launched, I'm going to make a cross-stitching of our first color composite of the moon and give it to Carly. And it took so long. It was a great idea that I thought of, but it took till well after the mission ended. And I had to run around and get everybody's signatures on the back of the pillow. But it was really an amazing experience. And being able to go connect with these people who had been involved in the mission a year later was really, really great. And then this is just a picture of the messenger team. So once after committing to go to APL, I ended up getting involved with the messenger team, which is a fantastic experience. And even though Mercury has no absorption bands in the near-infrared, which was painful, I was able to use the integrating of different data sets to really look at the composition of the surface and to understand how it evolved relative to other planets in the solar system. And then the last picture here is I I also participated in writing a large part of an asteroid mission proposal, asteroid called Mantis, that we submitted and got Cat 1. So we did, it was very successful, but not quite successful enough. But at the end of this, I used the skill that Sarah had taught me, how to bake, and made a bunch of asteroid diversity cakes and cupcakes. So the lessons I learned in grad school and postdoc, once again, try to look at things from other directions. Use different techniques in the lab, use different data sets from space, because you're not always gonna get what you want. But the answer's there somewhere. We're unraveling a puzzle, and we have all these little pieces of hints about the puzzle if you can put it back together. I also learned that cupcakes actually only cost about $3 to make, and they can come out of a box. I had no idea. Write proposals whenever you can. When you get them back and you know it's rejected, don't open it right away and get angry. Walk away. Take a deep breath. Think about, like, don't take it personally, and go back and read the reviews and remember what they were going, what the panel, they're all trying to do their best. Try to process it, take it with a grain of salt, and use it to make your next proposal better. And just keep trying. Because I was fortunate to start this field with 2 wins, and then a big loss in the Dawn PS, which like broke my heart for a little while. But you move on and you meet new planets, and it's okay. Mercury was great. Dawn is a giant piece of pyroxene, which kills me, so I'll get back to you, Dawn, I love you. So anyway, the people are really important. This is our Team Carly family picture, and I had to put Peter on there. That's Peter holding Alex at the hospital when he was born. And Noah is not looking towards the thing, so I figured I'd throw an extra picture of Noah on there. But, use your academic families for your future. Not use them, but use them for support. Use them for connections. Go back to them, appreciate them. And in my extended family, now that I'm at APL, I have worked with amazing people and people throughout the community. My dad passed away a couple years ago, and this was 4 years ago during the World Cup. I gave a talk at the Whispers engineering conference about my calibrations of Mercury data. And it was in Switzerland, and I thought, I can't go to Switzerland. Like, that's super expensive. And I'm like, all right, it's an invited talk, I'm gonna do it. And my dad was able to drive down from Germany, and he was able to meet my colleagues. He wasn't able to come to my defense or any of those things. So this was the first time he got to see what planetary science is like. And Patrick Panay and others were so inviting, and took us for beers and made him feel welcome. And it was just so important that he was able to see what a great, how great life has turned out. It's really, yeah, anyway, sorry, I'm getting, and then just a picture. I managed to get to the country that many of my ancestors are from, thanks to a trip leaving from EPSC last year from Latvia, and then an unfortunately foggy picture of some of my wonderful APL colleagues who have been great support over the years. So some of the lessons I'm still trying to work on. Say no to things. You don't want to say no to everything. You want to say a lot of yeses early in your career, but you want to be realistic. There was something in the James Webb report thing about the delay. They called it unjustified schedule optimism, and I think I need a tattoo that says unjustified schedule optimism, because I'm always like, I can make this work, I can do it. There's weekends, there's nights, but you can't, if you have family, even if you don't have family there, you've got family that birthed you, you have friends, you have all of these networks that you gotta hold on to and not become an island. So, take a step back, remember why you're there. Look at the stars, look at the moon, pull your car over, don't crash it. Just remember all of those things as you go through your careers. And my last little soapbox thing is just, we are here to do good science, but to do it with everybody else, collaborate. If you work on a mission, your job is to make those data as usable to the rest of the community as possible, and to teach the public about these solar system bodies. It's not to squirrel away with your data and become super famous and big superstar. We're not gonna be all Neil deGrasse Tyson or whatever, the public figure of our generation. We need to do our best to progress science forward. And there's so many problems to investigate. One of the first talks, I promise I'm almost done. I saw when I was in grad school was by Bill Feldman, and he just was like throwing out these things like, someone should do this, someone should do this, someone should do this. And I'm like, wow, like this is so different. This is a scientist who's like, not like, I have all this stuff I want to do. It's like, these are really exciting projects, and I want to see it done because I want to see the answer. So, you know, there you go. Anyway, thank you. Be crazy, be yourself. And, you know, if you get to where you're going a little slower than you should, at least you're true to yourself. And, yeah. Anyway, thank you for indulging me. Didn't even drink my water.